Hello. So very quickly, I'm going to go over how I've used the Aries Jupyter Playground to create a proof of concept of the interactions that a healthcare professional engages with as they navigate different stages of their career within the Scottish healthcare ecosystem. So, they have to pick up different credentials, like a GMC license, and they have to present them in different stages. So we're just going to show that in this Jupyter Playground. So we can actually run through the different interactions and see that it is possible to implement these complex systems within this environment. So very quickly, this is what the environment looks. This is the actors and the credentials. So red is the healthcare professional. They're going to be a medic, and this medic is, in the case, is a British citizen and also a human being. They're a Scottish resident. And, the medic is going to become a junior doctor. To become a junior doctor, they need to collect a GMC license, but they can't do that until they've completed their primary medical qualification. The junior doctor is going to be a hospital employee. To get a role as a hospital employee, they have to get this role assignment. And to get that, they're dependent on all of these credentials. So the right to work check, DBS check, basic training certificate, and immunity certificate. And these are all going to be issued by the Scottish Deanery, which the junior doctor participates in. The Scottish Deanery is this entity, that helps assign junior doctors to different hospitals as they go through their training. They want to become a fully qualified doctor. So the Scottish Deanery says, okay, go to this hospital, do this training. So we think the Scottish Deanery is a good organization to play this role of kind of turning these checks into something digital. So they're the actors. This is the flow. It's not too, you can just see it's quite complicated. There's a lot of credentials moving around. And I'm going to show you how I've implemented this within the Jupyter Notebook Playground. So to start with, this is the playground. You can clone this, right? Like you can clone it. And if you check out Project Scottish Healthcare, you'd be able to get all of this code, which I think is really cool. And you can see in the playground folder, we have our actors. So there's 5 actors: the healthcare professional, the Edinburgh Medical School, the General Medical Council, the Royal Infirmary, and the Scottish Deanery. And each of those actors has a set of services defined in the Docker Compose file. And we're going to spin up those actors. But before I do that, I'm going to run the VON network, because we're running this on our local network instead of using a public service, public ledger rather. And we need to write the DIDs for all of the actors, apart from obviously the healthcare professional, who isn't going to have a DID in this case. Now in this model, I've used the healthcare professional just as another Jupyter Notebook instance. Obviously, maybe they would have a mobile phone, and it would be possible to change this demo so that they used a mobile phone. I just found it easier to play around with it being in another Jupyter Notebook instance. Okay, so this is the VON network, the local instance running at 9,000. And I'm just going to write all these DIDs. I already have them here. These are the seeds. I'll show you where they're defined in a minute. Now, obviously, in some cases, we might not want all of these actors to be endorsers. And I think that's quite interesting to think through, which of these actors should be endorsers, which ones aren't going to be able to endorse, in a proper development environment. Maybe some actors have to ask their superiors, like, okay, I want to get this transaction onto the ledger. You can kind of build up that hierarchy, which I think is quite powerful. Okay, so they're all on the ledger, and I'll just show you. So let's take the GMC, for example. In the environment file, they have this Akamai wallet seed, and this is the thing that we just wrote onto. This like gets turned into a DID that we just wrote onto the VON network. Okay, and now I'm just going to start up the playground. I'll pause this while that gets going. Okay, so the Docker has spun up. All the services are now running. And you can see this Docker PS. You can kind of see all of the things that we've got running there, and that includes, the VON network nodes. Okay, and then the next thing you want to do is run this /scripts.getURLs. And you can see, so for each of our actors, like the healthcare professional, the deanery, the GMC, we've got a different URL. And And this is basically, imagine that these are running on different servers, right? Like in different parts, in each different organization. This is like their interface to talk to and interact with their agent, right? They all have their own agent as well. So I'm just going to open all these up. Okay, there you go. You can see I've got 5. So it goes GMC, and then this is the medical school. This is the healthcare professional. This is the Scottish Deanery. And then this is the hospital that the healthcare professional would be, onboarded into when they start work. So, very simply, you just need to go through and run each of these notebooks. And, this is something that I really like about these notebooks. Like, you can write the code, and get the code working, but you can also describe it, and you're able to describe it, in whatever way suits you, right? It depends on how you're using these. If these are, more technical to a technical audience, you could describe the technical aspects. Or you can also lift it up a level, say I was giving this demonstration to healthcare professionals, I could tailor what was in the notebooks to be specific to that demonstration. So as I say here, this is going to be done, by the secure GMC admins IT team, right? They would be spinning up some back-end system. They would make sure they have their public did, which we've already got. We've written it to the ledger. We don't have a transaction author agreement because this is on the bond network. We're just going to assign it as a public did, and then we write our schemas to the ledger. Right, and then we're going to write credential definition. Now, with the GMC example, I've implemented revocation. So, these credentials, like the GMC is issuing a credential to the trusted medical school. So say they go to the medical school and they say, hey, are you doing your processes correctly? Okay, here's a credential that you can show it. And then same with the license, right? Like the license in particular is something, it's kind of like a foundational credential for these healthcare professionals that you have to use all over, the healthcare ecosystem. So definitely it needs to be revocable. That's what this does. So we're running another thing from BC Gov, right? It's a service for revocation, a tail server, just locally. So again, then we're printing off these things, and these are just the identifiers that we'll use in our other notebooks. Make sure you terminate. So, the first thing we're going to do is go and regulate a medical school. Right, so this is just, same process, kind of like configuration that really you wouldn't be doing lots of times if you were running this in a more stable environment, right? So we've got our identifiers. We're going to create a connection. So this is something that you do all the time in this sort of notebook playground environment, right? You create this connection, you copy it, and then you go across to the medical school or whatever notebook for the actor that you're intending to interact with, and you spin it up. So these listeners are just how we receive and handle webhooks. So here we said, that the medical school knows who the GMC is. It knows the identifier for the GMC, so it can kind of trust the connections, trust the things that GMC actor will sign, because it can resolve the bids on the ledger. But you can see there, this is like a step of, messages getting sent backwards and forwards between the medical school agent and the GMC agent that then get emitted as webhooks and printed out here based on the code we've defined in these handlers. Okay, so we've made a connection. You can see over here the similar kind of code. Connection is now active. So that means we can populate the credential attributes and we can send a credential. You can see we've got this offer sent. These are the attributes that we've offered to issue against. The medical school can also view these actors, right? Like these attributes and decide, yes, I am the actor of medical school. Maybe they check that it's from the actual GMC agent. And then if satisfied, they can, fetch that request and, say, yes, please issue it to me. Yep. So bunch of output there. There are examples where you can look in more detail at what this output is, which I think is interesting. I'll go into that now. And then I'm just storing the credential, right? Like I've been offered it, I've received it, and now I'm saying, okay, put that in my wallet so I can use it later. and this is the identifier that I will use to retrieve it when I need it. Okay, so that's that sort of stage done, if you like. We could do some revocation, but I'm not going to do it now. So we terminate that, right? And then the next stage is the medical school needs to kind of do some initialization. Basically just a similar process, right? Like we're going to write a schema to the ledger. Maybe in some cases you'd use an external schema, right? Like maybe it's not the medical school's job to define what a primary medical qualification looks like. That could be done by some external party, like Education Scotland, for example. So yeah, there we go. We're writing this credential definition, taking a little bit of time because we generate the public keys. Got it. That's just this initialization stage done. And the reason I've split this out is because you can run this many times, but you only need to initialize the actors once, right? As long as you keep the VOM network running up and you don't wipe the databases. So, okay, this is the primary medical qualification. And this is just another kind of model of this diagram, right? We have three actors. We have the GMC, the Edinburgh Medical School, and the medic. The medic wants the Edinburgh Medical School to provide education to them. The Edinburgh Medical School needs the medic to pass their exams. And if they do that, then they can provide this primary medical qualification to them. And they also do this service where they introduce the medic to the GMC. So I think that's a really interesting point because it's like, here's where we can bootstrap a relationship, a digital relationship over DIDCOM. That would be established through a face-to-face interaction, with an introduction made by a trusted party, the medical school. Okay, and then here, I'm connecting with the medic. I'm just saying, where would this connection happen? Like, and that's really the decision for the system to decide, right? But it could be in the UCAS form, or it could be, through an email of acceptance. It's really, you can maybe create this relationship, this digital relationship with a medic and the medical school at like the beginning of their education, and then that could be used throughout their education to share messages, issue credentials, all that kind of like digital side of the medic being at university could be handled over this channel. Okay, so we've created an invitation. Obviously, the medic needs to connect with it. Maybe in real situation, they'd be using a mobile phone. But in this situation, obviously, we're just using this notebook environment. We copy in the invitation, we receive it, and we accept it. Okay, yeah, so this is a to-do. I mean, I haven't done it, but potentially the medic would then say, okay, can you show me that the GMC has vetted you and you're actually eligible to provide this medical education to me to a desired standard? Potentially that would happen, or at least it could happen, right? Okay, yeah, and this is just saying, we could display this as a QR code and you could scan this. Like, it would be possible to scan this because I've used ngrok with your mobile phone and, play the doctor as using a mobile phone. That is possible in this environment. And then the medical student has completed their education. We're assuming that the medical school kind of knows that out of bound and decides, okay, this student with this connection has successfully passed their qualifications. And we're going to send it. So, again, on this side, I'm receiving this offer. Maybe it comes from my mobile phone and I'm able to check, okay, this is from the Edinburgh Medical School, and it's basically saying that I have, this is my primary medical qualification. And it's not to say that this would replace the physical paper version, right? It's a way of like tying that paper version to a digital representation of it that would allow the medical student to use it and reuse it in a much more easy way, and that can be verified by other parties in this ecosystem. And in particular, as we'll see next, verified by the GMC. Okay, I'm going to store it, right? I've received it and I'm going to store it. I'm going to say, okay, let's save that as the PMQ. Now, a lot of this would be handled, by the implementation, not by the medical student. But I think it's nice that you can see the different parts of this system and how they work at like a good sort of layer. And then you can understand, okay, what do I need to implement? What should be the decision of the actual actor, like the medical student. Okay, the next step is going to be to receive a GMC license. So, like the GMC in the UK, that's the licensing body. Every doctor must have a license to practice in the UK. So GMC is like a really foundational actor within this system. It's setting some global identifiers, and I think this is just interesting in terms of it's saying like, okay, like here is the list of all the medical schools that we trust to issue these statements. It's kind of like a very basic example of a trust list or a machine readable governance, right? If the GMC is going to accept presentations of PMQs, then it needs to know which medical schools are able to issue these PMQs based on knowing that they're doing the appropriate, education. And I think this must already happen, right? The GMC knows, oh, these are all the medical schools within the UK that are providing, good enough education to medics that we can trust them and use them as a input for issuing GMC licenses. Basically, if you get PMQ from a vetted UK medical school, then you're going to be able to get a GMC license. And this is what I was saying before, right? Like the medical school is going to do this introduction face to face with every single medical student, right? So the GMC gets introduced to every medical student studying maybe in their final year, and and they kind of like have a chat and they say, oh, you're about to qualify. Here's how you get through this sort of like next stage, right? Because the GMC really wants medics, obviously, to get licensed and start practicing in the UK. So they're highly motivated to do this. And just the fact that this is a face-to-face interaction, means it's like a high trust first connection. So this isn't like just sent into the ether, this invitation, right? This would be, the medical student and the GMC agent. That actor comes in, they shake hands and maybe they show a QR code, right? Like on a device. So, there, like we've now accepted this connection. These two now have a digital connection that can extend beyond that first, in-person relationship into like a not present situation where they can communicate and have high confidence that the person they're communicating with is, either the GMC or the medical student. I think this is quite important, right? Like, this is kind of like an identifier, right? It gives us an identifier that we can use. It gives us an identifier, right, that the GMC can use in their like systems. Like maybe that's where they start to collect some like information. Maybe they take a picture of the medic. Like all this stuff that happens face to face in terms of data collection, data entry can then be associated with this connection identifier and maybe later used in the issuance of credentials. So as I said, obviously we can play a QR code again if we wish. So yeah, this is about collecting the key information, right? Like maybe in that meeting, I check some passports and I take a picture. And we take a picture and we save it on file. We say, okay, this medic is about to graduate. They've not got their PMQ just yet, but in the future, within the next 6 months, we expect them to. Here's their photograph that we can then use in their GMC license. The first thing we're going to do is, request a proof. And actually, maybe this would be different, right? Maybe it would be on the medic to propose to present, once they've completed their PMQ. Like, hey, GMC, like here, I've now completed my PMQ. Please issue me a GMC license. Okay, so as you can see, this is the request that we've been asked to submit, particularly saying like from this schema. searching for available credentials, and it says, okay, yeah, we can satisfy this request using our primary medical qualification. And obviously, this might be shown up on a phone, like it needs to be displayed in some user-friendly way, not in this kind of developer-friendly way, but I find this developer-friendly way really nice to be able to see like what's going on here, what's available for me to display. This is the actual stuff that gets sent between agents that we can then use to build more complex, more user-friendly systems on top of that. Okay, and then we're going to respond. We're going to send a presentation. The presentation is sent. We're going to fetch it. We're going to verify it, right? So this is verifying the cryptography. Like, was that presentation from a valid schema that we identified, and does the cryptography match the, are the attributes integrity assured? All that kind of stuff is then verified in this request, and we've seen it's valid. Okay, but like we said, that doesn't mean that we should trust it, right? It doesn't mean we should accept it because it might be issued by a bad actor. So, we do a basic check against our trust list, and say, was that issued by a DID that we know with a high degree of confidence is a medical school? And as you can see here, check, we passed that test. Now we can actually have a look at some of the information within there, right? Like this is the actual data that we got presented, and maybe that would be then used in issuing a GMC license, or maybe it would be used to kind of check the data that was collected in that initial meeting. Does the name match? Was this credential really issued to the same person? You can do some like extra checks, which I think add some value, reduce the risk. Okay, and then the next thing we're going to do is actually issue this credential. So we've got that headshot, which was like collected maybe in an in-person interaction. We're going to populate our credential. We're going to send it, right? And obviously this is quite a big bit of information. It's because here this is a base64 encoded image, which we populated in one of the attributes. Okay, so yeah, here we can go. This is the same offer being received on the other side by the medic. And now, obviously, this is kind of one of the hard bits, at least about the current indie network, is like, how does the medic know that the base64 image, how does the medic software know that the base64 image is indeed a base64 image that they need to render into an image, right? It's kind of all this sort of like extra semantics layer, which is the meaning behind the attribute names, is currently something that doesn't exist and is custom for each use case, I would say, at least in the indie side. And that's maybe where JSON-LD can come in and help. Okay, so we fetch that record, and then we're going to, I'm the medic. I want to find out, okay, what have I just been offered? What's contained in there? These are the attribute dates, right? Information, like my actual license number, which would be is every GMC person gets a license number, my name, all this kind of stuff. We can actually check it. And one of the cool things is, let me just show you that again, right? So like we've parsed this data. We've decided, okay, if this is base64 image attribute, we're going to write that to a JPEG file so we can use it later. So that's a JPEG file, and then we're going to look at it and say, oh yes, that's my image, right? Like, and that's really cool because this image is now stored in my wallet, or storable in my wallet, right? When I do this, finish this section, I can then present in other interactions. It's stored in my wallet, but it's been signed by the GMC, which gives me like a really powerful way to prove to other actors in this system, that I've been licensed by the GMC and that was indeed me, because my photograph matches. Which is why I think, in this sort of world, the GMC license, as it already is like foundational to the system, can become a, like an identity credential, if you like. I don't like the word identity, but, like a strong assurance to this is me. So I can pass some like pre-identity verification checks, as opposed to having to rely on like a passport and something else, which, like I've seen the list, it can get quite complicated at times if people can't match the two photographic ID and evidences. So this could create a way to kind of, healthcare professionals an additional way to pass those identity verification checks. Okay, and then we can check, has it been revoked, which it hasn't at the moment, right? Or I haven't revoked this credential. Sorry, you missed this, but these are the credentials that I collected. Well, I collected PMQ and I collected a GMC license. Yeah, okay, so that's kind of it. Like, I don't think I'll go too much further into this, but I think you can start to see, maybe I'll just show one last stage, which is, the doctor going to the GMC, going to the Scottish Deanery rather, and presenting this GMC license, and then the Deanery rendering that photograph. So the Deanery needs to do some initialization, but I'm not going to do this because, as I said, I'm not going to go into all of this. This is just going to be the last step that I'll show you. But if you're interested, you can run through this code yourself quite easily. It should just work, right? Like, you can get the installation to work, that is. So, same process, do this a lot. Indentation here, paste it in, and again, it's like, how would this connection be made? I think that's one of the key sort of points of this system is, different connections have different assurance based on whether they were established through a website, right? Whereas, compared to a face-to-face interaction, right? If the doctor's asked to come into the Scottish Deanery and, meet a person who's acting on behalf of the Scottish Deanery, who then shows them an invitation that they, establish, then, there's really quite high assurance that that person is who they're claiming to be, as opposed to, okay, go on this website and scan this QR code. It's really hard to tell, okay, was that the right person? And particularly if you're then asking them to present a credential signed by the GMC. Oh, yes, so I haven't sent that yet. Right, so we know he's established this invitation, and then we're going to send this proof request, right? We want them to prove to us that they have a GMC license, right? And let's have a look at this again. Sorry, I skipped over this, but we're asking them to prove these attributes, and they need to not be revoked. They need to have that's their image, their name, and then their GMC number. Okay, so that should now be sent. We can do this again. So you can see this is what they're asking for, and we can satisfy this using the GMC license credential. We have that stored in our wallet. Okay, so then we've presented that. We've created a presentation. We go over here. So this is the doctor image from probably when I run this before. We delete that. Presentation received. We're going to fetch this record. We're going to verify it. So again, we just checked, is this true, right? Like, has the cryptography been signed by the GMC? Which is. And then we're going to check the attributes. So, here what we've done again is we've said, okay, if it's base64 image, right? So we had to know that the image was going to be stored in this attribute that we've called base64 image. Then we're going to decode it and we're going to write it to a file called doctor image. And then again, the actual human actor who's meeting the doctor can display that image, right? And perform yes, that is the doctor who was issued this credential, right? Their photo match. It's kind of like a biometric check, but the doctor is in full control of who gets to do that biometric check on them, because they get to decide when they disclose the base64 image. Or maybe not full control, right? Like, obviously, but they at least have a say in how that image is used. And this is really interesting because in the GMC wanted to put images in the registry. So there's a public registry of all doctors licensed in the UK, and they wanted to put images in there, but doctors said, no, that's compromising our privacy. We can't have that. But this way, I think, is maybe something that they would be amenable to and would be positive for them, right? Because this GMC credential can then become a strong authenticator of who they are as a human individual that they could use throughout this ecosystem over and over again. So I'm going to finish there. Hopefully you can see, how this playground allowed me to build this and tell a story as we go along. Hopefully, I've not rambled too much. Yeah, I mean, I really would encourage you if you're interested and have a use case, right? Just clone the repo. Maybe don't, well, maybe check out the healthcare project, or just create your own branch and start working around with these recipes. Copy and paste them, chop and change them, and build something cool. Thanks.